So class, today we are doing 7-5 coordinate geometry. The ICANN statement is ICANN ID polygons in a coordinate plane.
Matthew, can you call on 4 different people one at a time to give the definition for slope? Go.
Ahmed. Rise over run. Go. M. Megan.
y1 minus y2 over x1 minus x2.
Peyton.
Changing y over changing x.
Matthew, the slope of a horizontal line is going to be what?
0.
0. And the slope of a perpendicular line, Jack, is what?
You mean vertical
I'm
line?
sorry, of a vertical line is what, Jack?
Undefined.
Is undefined. Thank you. When we go to number 3, Matthew, can you explain, not this one, but this one, can you explain why A, B, C, and D are defined as how they're defined? And by the way, D is down here. We were running out of room. Go, Matthew.
Okay, so D is a horizontal line, so it has to be 0. A is a vertical line, so it's undefined. B is a negative because you go down and then you go over, so it's a negative slope.
So we're talking about slope on all of these, right? Okay.
And then C is a positive slope because you have to go over and up.
So B is a negative slope because if I'm going from this point to this point, my rise is going to be a negative and my run is going to be a positive, right?
Yes.
We have a negative over top of a positive, therefore it's going to be a negative slope, right? And on C, from point black to second point black here, we have a rise of a positive and a run of a positive, right?
Yep.
So positive over positive is a
Positive.
positive. So therefore we call it a positive slope. Okay, you cool on that? Okay, and then could somebody help explain what is so unique about the slope of parallel lines? What is so unique about the slope of parallel lines, Bennett? Really loud.
Two lines with equal slopes and the lines are parallel.
So what's unique about parallel lines is their slopes are the exact same, right? So if you have two slopes with the exact, or two lines with the exact same slopes are parallel. Matthew, can you explain what's unique about perpendicular lines?
2 lines whose slopes have a product of -1 are perpendicular lines.
Can you go ahead and click to the next slide, Matthew, and show us an example of perpendicular lines who have a slope of -1, I'm sorry.
Perpendicular lines are C and D.
C and D?
Sorry, C and B.
C and B. So the slope of C here, so we're looking at line C, would be -1, 2, 3, 4, and a run of 2, right? So the slope of C equals -4 over 2, which is what, you guys?
-2.
And the slope of B, starting right here and going right here, rise of 2, run of 4, correct? So that would be B equals 2 over 4. Reduce it, what is it? 1/2, right? So if we take -2 and we take 1/2, -2, and we multiply it by 1/2, what is -2 times 1/2?
-1.
-2 over 2, which equals -1. So are we proving our theory?
Yes.
The slope of perpendicular lines, the product of the slope of perpendicular lines is -1. Matthew, anything to add to that?
No.
I have one more question. What does this mean?
Perpendicular.
What does this mean? Parallel. What does this mean?
Perpendicular.
Perpendicular. Any questions?